Class not yet started. So good morning, students. Good morning, everybody. First to take the screenshot of syllabus. After that we start. Myself, P. Venkatrao. I will teach engineering mathematics in AS Academy. First take the screenshots of syllabus. After that we will proceed. Good morning to everybody. Take the screenshot of syllabus. Syllabus screenshot you have to take. Screenshots you have to take. Morning to everybody. So take the screenshots. Now start the session. Probability. Myself P. Venkatrao. I will teach engineering mathematics in AS Engineering Academy. Probability, the weightage in the gate examination should be around 3 marks. Moreover, you may be given 1 or 2 marks from aptitude also. Aptitude also. So overall weightage for probability and statistics in the gate exam should be 4 to 5 marks. Now let us see in definition random experiment. So what do you mean by random experiment? Listen to me. Outcome of an experiment cannot be predicted, cannot be estimated, cannot be guessed, but it should be any one among several possible outcomes. First basic definitions followed by problems. So the outcome of an experiment cannot be predicted, but it should be any one among several possible outcomes. For example, before going to toss a coin, you don't know what the exact outcome is, but we can guess the outcome is either head or tail. Similarly, before going to throw a die, we don't know what the outcome is exactly, but outcomes can be predicted as 1 or 2 or 3 or 4 or 5 or 6. That means exact outcome of an experiment cannot be predicted, guessed, but it should be any one among several possible choices like 1, 2, 3, 4, 5, 6. That type of experiments are said to be random experiments. Write the definition. The outcome of an experiment cannot be predicted, but it should be any one among several possible outcomes. The experiment this experiment is called a random experiment. Example 1, tossing of a coin. Example 2, throwing of a die. Next definition. Mutually exclusive, mutually exclusive events is also called mutually disjoint events. What do you mean by mutually exclusive events? Very simple. Listen to me. Occurrence of one event prevents. Prevents means what? Restricts. Prevents means restricts. Means opposes. Occurrence of one event prevents occurrence of all other events. Then all those events together are said to be mutually disjoint or mutually exclusive events. For example, a coin is tossed. Occurrence of head. You are getting head means you are not getting tail. That means occurrence of head prevents, restricts occurrence of tail. Okay. Occurrence of head prevents occurrence of tail. So therefore, occurrences of heads and tail are mutually exclusive events. Mutually exclusive events. Otherwise, you may remember like this also. Two or more experiments, two or more events cannot occur at a time. Then all those events together are said to be mutually exclusive events. For example, a coin is tossed. Head and tail cannot occur at a time. Therefore, head and tail are mutually exclusive events. A die is thrown. 1, 2, 3, 4, 5, 6 cannot occur at a time. Therefore, 1, 2, 3, 4, 5, 6 are mutually exclusive events. Two or more events cannot happen at a time. All those events are said to be mutually exclusive. Write the definition. The occurrence of one event prevents the occurrence of remaining events then the events are said to be mutually exclusive. I will go to the next slide. Next slide. Now voice, is it clear? My voice, is it clear, students? Voice, is it fine? I mean audible and clear? Okay, thank you. I'll try to internet connectivity and everything is fine. We'll see. Now, what I said, mutually exclusive events means two or more events, that is two or more events cannot occur simultaneously. Remember, two or more events cannot occur simultaneously, then all those events together are said to be mutually exclusive. Another definition. Another definition of mutually exclusive events. Even you may write like this also. Remember, if A intersection B is equal to phi, phi means what? Null set. Null set means what? Empty set. If A intersection B is equal to phi, then A and B are mutually exclusive events. You can define like this also. This is another definition. If A intersection B is equal to phi, then A and B are said to be mutually exclusive events. Example, remember, if a coin is tossed, head and tail cannot occur at a time. Therefore, head and tail are mutually exclusive. If a die is thrown, 1, 2, 3, 4, 5, 6 cannot occur at a time. So 1, 2, 3, 4, 5, 6 are mutually exclusive events. Two or more events cannot occur at a time. All those events are said to be mutually exclusive. If a coin is tossed, then head and tail are mutually exclusive events because head and tail cannot occur at a time. Therefore, those are mutually exclusive events. Diagrammatically, you can show like this. There is no common area between two circles. There is no common area between two circles. Then those two circles are mutually exclusive. Mutually exclusive events means no common area occupying between two circles. Then those two circles are Venn diagram format mutually exclusive. Suppose there is some common area between two circles. There is some common area between two circles. Then those two circles are not mutually exclusive events. So there is some common area between A and B. Therefore, A and B are not mutually exclusive in the second diagram. First diagram mutually exclusive, second diagram not mutually exclusive. Next definition. First basic definitions. Once basics are completed, then only we can solve the problems. Mutually independent events. Mutually independent events. Listen to me. Occurrence of one event does not influence occurrence of the remaining events, then the events are said to be mutually independent. Suppose a coin is tossed first time, head occurs. For example, assume head occurs. Same coin tossed second time, by chance head occurs in the second trial also. Therefore, why did you get head in the second trial? Because of getting head in the first trial? No. That means occurrence of head in the first trial is not influencing occurrence of head in the second trial. Then occurrences of heads in the first and second trials are mutually independent. Means occurrence of one event does not influence occurrence of other events, then all those events together are said to be mutually independent. Write down. If the occurrence of one event does not influence the occurrence of other events, then the events are said to be mutually independent. Example, if a coin is tossed twice, then the occurrence of heads in the first and second trials are independent. And definition: sample space. What do you mean by sample space? Very simple to say. The set of all possible outcomes of a random experiment is called a sample space. For example, a die is thrown. What are the possible outcomes? 1, 2, 3, 4, 5, 6. So the set of all possible outcomes of a random experiment is called a sample space and is denoted by S. Right now. the set of all possible outcomes of a random experiment is called sample space. And is denoted by capital S. Example, if a die is thrown then the sample space means set of all possible outcomes of a random experiment. That is called a sample space and is denoted by S. Next slide. In definition, probability. So, what is the definition of probability? Very, very simple to say. Suppose an experiment is conducted n times. If an experiment is conducted n times, one particular event E occurs in m different ways. If one experiment conducted n times, if one particular event occurs in m different ways, then the probability of occurrence of an event E is defined as m by n. M by n. Right down. If an event E occurs in m different ways, out of a total of n cases, then the probability of occurrence of an event E is defined as P of E is equal to favorable cases to the total cases. Favorable cases M, total cases N. m by n. Probability of occurrence of one event is favorable cases by total cases. Now, probability of a non-occurrence of one event. Non-occurrence of one event is written as E complement or E bar. Probability of occurrence of one event is favorable cases by total cases. Probability of non-occurrence of one particular event is unfavorable cases, not favorable cases by total cases. Out of n cases, m cases are favorable for occurrence of one particular event E. So how many cases not favorable? I mean unfavorable. N minus m cases unfavorable by total cases n. So this is n by n, 1 minus m by n. So m by n means P of E. M by n means P of E. Next slide. So P of E complement is equal to 1 minus m by n. M by n means P of E. So probability of non-occurrence of one particular event is equal to 1 minus probability of occurrence of another event E, or P of E okay, fine. Next. P of E is equal to 1 minus P of E complement. That means probability of occurrence of one event is equal to 1 minus probability of non-occurrence of same particular event E, or P of E plus P of E complement is equal to 1. Mutually exclusive event screenshot on just 1 minute. Please remember this. Whatever I particularly mentioned to remember, you need to by heart. Mutually exclusive events. Definition: the occurrence of one event prevents occurrence of remaining events, then the events are mutually exclusive. And this is the another definition also. If A intersection B is equal to phi null set, phi means null set, A and B are mutually exclusive. Diagrammatically, mutually exclusive means no common area between A and B, then A and B are mutually exclusive. There is some common area between A and B, then A intersection B not equal to phi. Means A and B are not mutually exclusive. Okay. This is the first topic. If anyone comes late, please take the screenshot, and from now everyone follow me carefully. Actually, from the beginning I am giving, take the screenshots. Next. And from now, you should carefully follow me. Next. This is 8th edition. Next. 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 I will tell you how to prepare, and all of you, whatever I teach the problems in the classroom, and actually we have volume 1, volume 2. Volume 1 booklet problems will be taught by concerned faculty, and they will be given volume 2 booklet that has more number of practice problems with the detailed solutions. Or volume 1 booklet problems I will teach in the classroom, plus some of the previous gate questions I will teach in the problem in the classroom, and some of the another competitive exams like ISRO or TIFR, Tata Institute of Fundamental Research, and some other problems also I will teach in the class. That would be more than sufficient. In the future, if you have any clarification purpose regarding conceptual, you can go through the books. Otherwise, not required. Next. Axioms of, now follow me carefully. Axioms of probability. Do you know the difference between theorem and axiom? Difference between theorem and axiom means, theorem means a statement which we can prove. Axiom means a statement which we cannot prove. That is but both are correct statements. Theorems can be proved, axioms cannot be proved. Theorems can be proved, axioms cannot be proved. Condition number 1, 0 less than or equal to P of E less than or equal to 1 means probability of occurrence of any event always lies between 0 and 1, including 0 and 1. Condition number 2, P of X is equal to 1, P of S is equal to 1 means probability of sample space is equal to 1, means sum of the probabilities of one random experiment is 1. For example, a coin is tossed. Possible outcomes are head and tail. So probability of head plus probability of tail is 1. If a die is thrown, possible outcomes 1, 2, 3, 4, 5, 6. So probability of 1 plus probability of 2 plus 1 probability of 6 is 1. Probability of sample space is equal to 1 means sum of the probabilities of one random experiment is 1. Next. If A and B are mutually exclusive events, then P of A union B then P of A union B I will write in the next slide. There is no place sufficient here. I will go to the next slide. If A and B are mutually exclusive events, next slide, then P of A union B, P of A union B is equal to P of A plus P of B. P of A plus P of B. So these are the axioms of probability. And remember, whenever you wish to find favorable cases as well as total cases, first of all, you must have minimum knowledge about multiplication rule, also called fundamental rule of counting, as well as permutations and combinations. Minimum knowledge is required. That's why let us briefly review fundamental rule of counting means multiplication rule, as well as permutations and combinations. After that, we do problems. Right on. Fundamental don't worry. Some students, one student Ojasvi, you asked the difference between mutually exclusive and independent events. Don't worry, I will explain. I will explain the difference between mutually exclusive and independent events. So once we start the problems on independent events, wait until independent events. Problems on independent events. There we will be going to solve problems on mutually exclusive and mutually independent. For example, because first of all, you must know the definition of mutually independent events. Mutually exclusive events means P of A intersection B is equal to P of A into P of A intersection B is equal to 0. A and B are mutually exclusive. Mutually independent events means theoretical definition completed and formula wise definition I did not give. Actually, that is the fourth or fifth topic. There I will teach. P of A intersection B is equal to P of A into P of B. Then A and B are said to be independent events. P of A intersection B is equal to 0. Then A and B are mutually exclusive. Based on these two statements, we can do problems. Mutually exclusive events will never be independent and vice versa. Mutually independent events will never be mutually exclusive unless otherwise both probabilities are zeros. I will explain there. Until then, please wait. Otherwise, till you want right now only, I can explain, because we will be doing problems on mutually exclusive and independent separately, and one problem I will teach on both mutually exclusive and independent also. Until then, you wait. If you want right now, I will teach also. Let me complete fundamental rule of counting. Listen to me. Suppose one experiment is conducted in m different ways. One experiment is conducted in m different ways. After conducting the first experiment in m different ways, then you are left with n choices only. You are left with n choices to do the second experiment. Then the first and second experiments can simultaneously, then the first and second experiments can be done one after other, first and then followed by second in m into n ways. This is the fundamental rule of counting. For example, look here, all of you. One person has three different colored trousers, or one person has four different colored trousers, means four different color pants, and the same person has three different colored shirts. Let it be S1, S2, S3. Then how many possible combinations we can choose? First you select trouser 1. Along with the trouser 1, you can select shirt 1. Along with the trouser 1, you can select shirt 1 or shirt 2 or shirt 3. Along with the trouser 1, you can select shirt 1, shirt 2, shirt 3. Similarly, you can select a trouser 2. Along with the trouser 2, you can select shirt 1, shirt 2, shirt 3. So T2S1, T2S2, T2S3. Or you can select shirt trouser 3. Along with the trouser 3, you can select shirt 1, shirt 2, shirt 3. Or you can select trouser 4. Along with the trouser 4, select shirt 1, shirt 2, shirt 3. So T4S1, T4S2, T4S3. Total how many? 4 3s are 12. But counting in this manner will consume lot of time. That's why we need to apply fundamental rule of counting. There are four possibilities to select a trouser 1. We can select a T1 or T2 or T3 or T4. Four possibilities to select a trouser 1. After trouser 1 has been selected, then you are left with three choices to select a shirt, S1 or S2 or S3. Then one trouser, after that one shirt can be selected one after other sequentially in 4 into 3, m into n, 4 into 3, 12 ways. So fundamental rule of counting is one work can be done in m different ways. After completing the first work done in m different ways, you are left with n choices to do the second work. Then the first and second works can be done one after other. First work and then followed by second work. Sequentially, one after other can be done in mn ways. Right now, definition. If a work, assume work as W1. If a work W1 can be performed in m different ways and a second work W2 can be performed. Remember, second work is done only when after the first work is completed. That is important. Can be performed within the brackets after W1. W1 means first work. After W1 has been performed in any one of m different ways in second work, this is in n different ways, then the two works, first work and second work, can be done one after other. Then the two works one after other. First work we have to do first and then second work, one after other, can be performed in mn ways. Next slide. Going to the next slide. Example. If a man has four different colored trousers, T1, comma, T2, comma, T3 and T4, and three different colored shirts, S1, comma, S2 and S3. Then he can select a pair. He can select a pair means what? First he has to select a trouser and then a shirt. In 4 into 3 is equal to 12 ways. That is m into n, fundamental rule of counting. There are m possibilities to do the first work. After completion of the first work, there are n possibilities to do the second work. Then the first and second works can be done sequentially one after other in m into n ways. That is fundamental rule of counting. Now let us briefly review permutations and combinations followed by problems, briefly only, because whenever you wish to find favorable cases as well as total cases, you need to use permutations and combinations. That's why briefly we'll see. Basics important. Let us write points wise. First one, permutation or arrangement. Permutation or arrangement. Permutation or arrangement. Remember, order is important. For arranging the objects, permutation means arranging the objects. For arranging the objects, order of arrangement is important. Order is important. Listen to me. You are given 4 letters A, B, C, D. Out of 4 letters, any 2 letters can be arranged in a line. Out of 4 letters, any 2 letters can be arranged in a line. Any 2 letters can be AB, AC, AD. Any 2 letters can be AB, AC, AD. Or BC, BD, CD. Any 2 letters can be AB, AC, AD or BC, BD, CD. AB. AB we can arrange like this. AB one arrangement, BA is another arrangement. Now AC. AC can be arranged like this or CA. AD. AD can be arranged or DA. BC can be arranged like this or CB. BD can be arranged as BD, DB. Now CD, DC. So out of 4 letters, any 2 letters can be arranged in how many ways? 4p2 ways. What is the formula for 4p2? 4p2, 4 factorial by 4 minus 2 factorial. So this is 4 factorial is 4 into 3 into 2 into 1, 24. 2 factorial is 2. So answer 12. So therefore 4p2 value 12. 4p2 value 12. We have already seen 12 cases here. But every time writing the possibilities in this manner will consume lot of time. So that's why you should not write like this. Out of 4 elements, any 2 elements can be arranged in 4p2. 4p2 means that is 12. Out of 4 elements, 2 elements can be arranged in 4p2. Out of n elements, r elements can be arranged in npr ways. NPR formula n minus r factorial. Or we can do this box method also. All arrangement problems can also be solved using box method. You are given 4 elements. A, B, C, D. So out of 4 elements, any 2 elements can be arranged in a line. Any 2 elements can be arranged in a line. This is the first box. In this first box, we can write A or we can write B, or we can write C, or we can write D. There are four possibilities to fill the first place. Once the first place is filled by any one of the four elements, A or B or C or D, four possibilities. After the first place is filled by one of the element, then you are left with three choices to fill the second place. We can write A here or C here or D here. There are three possibilities to fill the second place. Therefore, total number of possibilities 4 into 3, 12. Fundamental rule of counting. One work can be done in m ways. Means one box can be filled in 4 ways. After filling one of the box, you are left with three choices to fill the second box. Therefore, first and second boxes can be filled one after other in m into n ways, according to fundamental rule of counting. Right on? The number of permutations of n different things taken or at a time is NPR. Formula n factorial by n minus r factorial. Next slide. Next slide. Permutation in the sense both arrangement and selection. Yes. See, one student asked permutation means arrangement and selection. Muralidhar Reddy, look here. You are given four elements. Out of four elements, you need to arrange any two elements in a line. So first of all, out of four elements, select any two elements. Selection of any two elements out of four elements is 4C2. Selection of any two elements out of four elements is 4C2. The selected two elements can be arranged in a line. The selected two elements can be arranged in a line. That is two ways. Here two possibilities, here one possibility. 4C2 into 2, that is 4P2 only. Permutation means select and arrange. Selecting any two out of 4C2. And then arranging any two elements in a line is 2 factorial. 4C2 into 2 factorial, that is 4 factorial only. 4 factorial only. Select and then arrangement, that is correct only. Write down. Example. Consider four letters A, B, C, D. Next slide. Number of ways of arranging any two letters out of 4 is 4p2 is equal to 12. Out of 4, any two letters can be arranged in a line. First letter can be arranged in the first box in 4 ways: A or B or C or D. So after filling the first letter, then we are left with 3 elements only. Therefore, the second place can be filled by any one of the remaining elements, that is 3 ways. Therefore, first work and second work can be done one after other sequentially in m into n ways, that is 4 into 3 ways, 12 ways. Next. Let me briefly review circular permutation. Circular permutation. Look here, you are given look, 4 students seated around a round table. Then you cannot say what is the first place, what is the last place. That's why, as far as circular permutation is concerned, first of all, we need to fix. First of all, you need to fix one of the position. Regarding circular permutation, we suppose 4 students sitting around the round table. We don't know what is the first place, what is the last place. That's why you need to fix any one of the position permanently. I want to fix position A permanently. And you need to arrange the remaining objects just like line arrangement only. Just like line arrangement only. A is the permanent fixed position. We should not touch that. Now I fix B temporarily. I fix B temporarily only C and D. I fix B temporarily only C and D, changing their positions. Now B has been fixed temporarily, C and D changing their seats. Now let us fix C temporarily. A is the permanent fixed position. Don't touch that. C has been fixed temporarily. Only B and D changing their positions. Changing their positions. A is the permanent fixed position. C has been fixed temporarily. Only B and D changing their seats. B and D changing their seats. A is the permanent fixed position. C has been fixed temporarily. Now let us fix D temporarily. Only B and C changing their positions. A is the permanent fixed position. Don't touch that. D has been fixed temporarily. Only B and C changing their positions. Therefore, 4 students seated around a round table. 4 students seated around a round table in how many ways? 6 ways. I mean 4 minus 1 factorial ways. So 3 students seated around a round table in 3 minus 1 factorial ways. N 4 students can be seated around a round table in 4 minus 1 factorial, 3 factorial, 6 ways. 3 students, 3 minus 1 factorial ways. N students can be seated around a round table in n minus 1 factorial ways. Go back. Write down. Right. The number of write down. The number of circular permutations of n different things, n different things taken all at a time is equal to n minus 1 factorial base. Example, consider 4 letters A, B, C, D. The number of circular permutations is equal to 4 minus 1. Number of circular permutations of 4 letters is 4 minus 1 factorial, that is 3 factorial, that is 6. Going to the next slide. Going to the next slide. Next slide. Next slide. Circular permutation means suppose 3 students seated around a round table. A, B, C. Suppose 3 students seated around a round table. Then do you know what is the first place of the student? What is the last place of the student? You don't know. That's why as far as circular arrangement of objects means if you are arranging objects like beads of the necklace or flowers in the garland, what is the first position of the flower in the garland or what is the second position of the flower in the garland, we cannot say. That's why regarding circular permutation, you have to fix any one position permanently. After fixing any one element, I can fix up A or B or C. After fixing one of the position, then you need to arrange the remaining objects just like line arrangement only. A permanently fixed. So now you write B here, you write C here. You should not touch A. With respect to A only, you need to arrange B and C just like line arrangement only. The way you arrange B and C just like line. A is the permanent fixed position. Only B and C you need to arrange them. Now, number of possible different arrangements are B and C changing their positions. Now, three people ABC can be seated around a round table in two ways. Three people can be seated around a round table in two ways. 3 minus 1 factorial ways, two ways. Similarly, four people can be seated around a round table in 4 minus 1 factorial ways, that is six ways. Similarly, n students can be arranged around a line in n minus 1 factorial ways. N minus 1 factorial ways. So remember it as a formula. Next, write down. Permutations with constraint repetitions. Okay, fine. If you have any doubts, you can enter in the question and answers. Sure, I will give. Sariti. Next slide. With the constraint repetitions. Now, write down. Suppose you are given 20 fruits. You can fix A, or you can fix B, or you can fix C. Fix any one position. After that, remaining elements you can fix just like line arrangement only. So you can fix any one of the position. We should not write all possibilities. Suppose C fixed, you can arrange A, B, D. That's it. You should not think that one time A fixed, another time B fixed, another time C fixed, another time D fixed. These are not the possible combinations. Four different elements can be arranged in how many ways? Fixing position should be any one. We should not write all combinations. Fixing position should be any one. After that, BCD only. Not four, same story is repeated 4 times, 4 sixes are 24 is wrong. Fix any one position. Suppose four students, one student Madhu, another student Rohini, another student Srinu, another student Venkat, seated around a round table. What is the first position of the student? What is the last position of the student? We don't know. That's why you four people assume one of the student fixed permanently at one place. After that, remaining students you need to arrange just like line arrangement only. And don't try to say that second time I will fix another student, third time I will fix another student. That is wrong. Only one student fixed permanently and remaining you need to arrange. Now look here, permutations with constraint repetitions. For example, you are given 20 fruits. Out of 20 fruits, 5 apples, 4 bananas, 4 mangoes, and 3 guavas, and the remaining fruits are different category fruits. Different category fruits. You are given 20 fruits. You are asked to arrange 20 fruits in a line, but some of the fruits are identical fruits, same objects, 5 apples. Then what is the possible way of arranging all these fruits in a line? We see. No doubt. The number of permutations of n things in which p things are of type 1. P things are of type 1. You are given n fruits. So out of n fruits, p things are of type 1 means p fruits are belonging to same category. I mean, p fruits are apples. P fruits belonging to same category. P things are of type 1, comma, q things are of type 2, comma, r things are of type 3, and the remaining means rest, and the rest are different. Is given by n factorial by p factorial, q factorial, r factorial. Remember, total number of elements total number of elements n. Out of n elements, p elements belonging to one category, q elements belonging to second category, r elements belonging to third category, remaining are different. Then the number of ways for arranging them in a line means arrangement, some of the objects are repeated, is n factorial by p factorial into q factorial. So tell me the answer now. You are given 2, 5, 9, 12, 17 elements you are given. Total number of elements is 17. It's a formula. Suppose we have a derivation. It's not a direct formula. We have a derivation. Repetitions elements by choosing the elements like this. We can choose ROO2. You are given 4 elements, of which 2 elements are repeated. The first element, let it be O, second O2 T. Number of possibilities, tell me, are first O, second O, T. Next R, second O, first O, T. Next RT, first O, second O. RT, second O, first O. Next to TR, first O, second O. TR, second O, first O. This is the way we try to write all possible combinations. this type of all possible combinations values will be equal to this n factorial by p factorial into q factorial, it will come. So total 17 elements. So 17 factorial divided by a repeated twice, 2 factorial, b repeated 3 times, 3 factorial, c repeated 4 times, 4 factorial, d repeated 5 times, 5 factorial. If you have any doubts, please enter in question and answers only. There I can answer. Still you have doubts, at the end of the session, all your doubts will be clarified. All your doubts will be clarified. These many ways are possible for arranging all these lines in a line. N should be 20. Why n should be 20, where n 2, 5. Okay, 5 plus 4, 9, 9 plus 3, 12, 12 plus 5, 17, total 5, 4, total 17 elements only. A repeated 5, 2 plus 3, 5, 5 plus 4, 9, 9 plus 3, 12, and 12 plus 5, 17. Non-repeated elements not required to write. Non-repeated elements not required to write. I will tell you a good example. Now, example number 2. Mississippi. Tell me the spelling of Mississippi. This is the spelling of Mississippi. The question is, how many different possible arrangements can be made? How many different possible arrangements can be made? See, circular arrangement, if you do not fix any position, then no formula. Regarding circular pyramid, see, suppose you consider the beads of the necklace. What is the first position in the bead? What is the first position in the bead and what is the last position in the bead? We cannot say. Or you consider flowers in the garland. What is the first flower? What is the last flower? You cannot say. So that's why regarding circular permutation, first it is compulsory to fix one position. If you do not fix any one position, then circular arrangement not possible. Look here, how many different arrangements can be made from the letters of the word Mississippi. Total how many elements? 5, 11 elements. Total number of elements factorial in the numerator. Denominator, repeated elements. I repeated 4 times, 4 factorial. S repeated 4 times, 4 factorial. P repeated 2 times, 2 factorial. These many ways possible for arranging the letters of the word Mississippi. Next. You answer this question. Abracadabra. Try yourself. 4, 6, 8, 11. A repeated 1, 2, 3, 4, 5. B repeated 2 times. R repeated 1, 2. That's it. Next to definition. Going to the next slide. Yes, correct. Definition: combination or selection. Order is not important. Yes, circular permutation with constraints repetitions will work. Correct only in case of identical things only. In case of identical things. Right now, selection. Look here, you are given 4 elements A, B, C, D. For selecting the elements, order of selection is not important. Select any two. Any two means what? AB, AC, AD. Any two means AB, AC, AD or BC, BD or CD. Any two means AB, AC, AD, AB, AC, AD, BC, BD, CD. Out of 4 elements, there is no any formula for circular permutation with the repetitions. Suppose all elements are same elements, then it is one only. If each element is a different element, then n minus 1 factorial. All are identical elements, only one way to arrange. Different elements, n minus 1 factorial. Now, out of 4 elements, first concentrate here. You are concentrating here only. Break will be given. Let me complete theory. So, out of 4 elements, any 2 elements, I can choose AB, AC, AD or BC, BD, CD. So, out of 4 elements, any 2 elements can be selected in 4 C2 ways. 4 C2 ways. 4 C2 value 6. Similarly, out of n elements, R elements can be selected in NCR ways. NCR ways, formula n factorial by R factorial into n minus R factorial. I know. Next definition, the number of the number of combinations of n different things taken or at a time. Taken or at a time. is NCR is equal to n factorial by r factorial into n minus r factorial. Example, consider four letters A, B, C, D. Write down. Number of possible selections of any two out of four is 4C2 is equal to 6. First combination AB, AC, AD, BC, BD, any two AB, AC, AD, BC, BD. Next CD. Next slide. Basic definitions completed. Now, next slide. Break will be given. Root example, I will teach you, anonymous attendee. Definitely I will teach you. Write down. Note. Break will be given. Why you are worrying? Even 1.5 hours not completed, you are asking break, 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 break again. Note. First of all, write De Morgan laws. Concentrate on writing, not on typing questions. Concentrate here, my humble request. Break will be given. You must have a patience of sitting at least 2 hours. Otherwise, how will you write GATE exam for sitting 3 hours if you are unable to sit at least 2 hours? First theory let me complete. After that, break will be given. De Morgan laws. A union B whole complement is equal to A complement intersection B complement. Complement or bar, both have same meaning only. A intersection B whole complement is A complement union B complement. Next, addition theorem for two events A and B is P of A union B is equal to P of A plus P of B minus P of A intersection B. Similarly, addition theorem for three events A, comma B and C is P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. Next slide. Next slide. Yes, permutations, combinations, there is some relationship. There is some relationship between permutations and combinations, Sai Kiran. Actually, first combination out of n elements, R elements can be selected in NCR ways. Permutation means arranging. If you want to arrange the objects, first of all, you need to select the objects and then arrange them. So out of n elements, R elements are to be selected in NCR. Now R elements in my hand. Now these R elements can be arranged in a line. These R elements can be arranged in a line. First element, there are, see, in the first place we can write any one of R elements. In the second place, once one element is fixed here, you are left with R minus 1 elements. Second place can be filled in any one of R minus 1 ways. Third place can be filled in any one of R minus 2 ways. Last one. This is NCR into R minus 1 into R minus 3 into R minus 4 into so on into 1. That is NCR into R factorial. That is NCR into R factorial. That is NPR only. Please verify. There is a relation between permutation and combination. Next. Write this. Mathematically, at least, dictionary meaning of at least will be minimum. Mathematical meaning of at least or minimum will be greater than or equal to. Dictionary meaning of at most is maximum. Mathematical meaning of at most is less than or equal to. Next. One minute. So write down Venn diagrams. This is circle A. This is circle B. De Morgan law. One student has asked De Morgan law applicable for 3 events. Not only for 3 events. De Morgan law is applicable for 2 events, 3 events, 4 events, even n events also. A union, B union, A1 union, A2 union, so on union AN is equal to A1 complement intersection A2 complement intersection A3 complement, so on intersection AN complement. For n number of events, all formulas are valid for n number of events, not for 2 particular cases. Then it will not be a formula. Only valid for 2 events, it is not a formula. Anything is applicable for n number of events. So this is A intersection B. This is A, this is B. This is A intersection B complement. A intersection B complement means, remember, B complement means area occupied by circle A is deleted. Sorry, 1 minute, a small modification. This is A, this is B. A intersection B complement, that means area occupied by circle B is deleted completely, and the remaining area in circle A is considered, and the remaining area in circle A is considered. Area occupied by circle B is deleted, and the remaining area in circle A is considered. That is the diagram of A intersection B complement. Similarly, this is A, this is B. A complement intersection B. That means area occupied by circle A. Area occupied by circle A is deleted completely. Area occupied by circle A is deleted completely, and the remaining area only in circle B is taken. Remaining area in circle B is only taken. And next diagram. A union B. We all know this is A, this is B. This is the diagram of A union B. Now, A union B whole complement. That means area occupied by circle A union B. Area occupied by A union B is deleted. A union B whole complement means area occupied by A union B is deleted and the remaining area is considered. And remaining area is considered. Remember, A union B whole complement means A complement intersection B complement. This is A, this is B. Here A intersection B whole complement. A intersection B whole complement means A complement, De Morgan laws, A complement union B complement means area occupied by A intersection B. Area occupied by A intersection B is deleted. Area occupied by A intersection B is deleted and the remaining area will be considered. One small request to all, please draw yourself A union B complement Venn diagram. I'm not drawing. If you are unable after the break, I will let you know. Still, A union B complement. This A union B complement. Draw yourself. Draw yourself. Next slide. Next slide. A union B complement, think and then draw. I'll give the break. You must have patience here. Look. Next, playing cards. Total, how many playing cards? Everyone can say. Okay, previous slide. A union B complement Venn diagram I did not give. You were asked to draw. You were asked to draw A union B complement. You have to draw. That is not A union B complement. Next cards. Playing cards. Total, how many playing cards? Total 52 playing cards. Yes, B complement only. Total 52 playing cards. Out of 52 playing cards, we have 26 red cards. 26 red cards means 13 diamonds and 13 hearts. Out of 52 playing cards, 26 cards printed in red color. Diamond symbols and heart symbols are printed in red color, and 26 cards printed in black color. That is 13 spade symbols. This is spade symbol plus 13 club symbols. Diamonds and hearts are called red cards. Spades and clubs are called black cards. Diamonds and hearts are red cards. Spade symbols and club symbols are black faced cards, black cards. Total face cards. Face cards means what? Jocks, jocks, queens and kings. Jocks, queens and kings. Are called red cards. So total number of face cards are how many? Ace is not a face card. Ace is not a face card. Ace is not a face card. Only jocks, queens and kings are face cards. JQK are face cards. What happened? Not 16, 12, 12. Total number of face cards. Count 13 diamonds. In diamonds, we have JQK. In hearts, we have JQK. In spades, we have JQK. In clubs, we have JQK. So total 12. Remember, Ace card, not Ace Academy. Ace card is not a face card. Only jocks, queens and kings are face cards. Next. I am going to the next slide. Write down. All of you completed just 1 minute before solving the problems. If you want, I will give the break just 1 minute. One minute you have to wait. Write this also. Tossing of a coin experiment. Concentrate here instead of concentrating there. Tossing of a coin experiment. And diamonds and hearts are red cards. Spade symbols and club symbols. This is spade symbol and this is club symbol. Kalavari. This is spade symbol. This is club. This is spade. Spade symbols and club symbols are printed in black color. And that's why spade symbols and club symbols are black cards. Write down. Suppose one coin is tossed. It can turn up on the ground in two ways, either head or tail. Two coins are tossed. They can turn up on the ground in four ways: head head, head tail, tail head, tail tail. But instead of counting like that, use a fundamental rule of counting. Suppose the first coin can turn up in two different ways. Second coin can turn up in two different ways. Third coin can turn up in two different ways. Three coins can turn up into 2 into 2 into 2, 2 power 3 ways. Fundamental rule of counting. One work done in m ways. Second work done in n ways. Third work done in p ways. Then three works can be done one after other in m into n into p ways. First coin can be tossed in two ways. Second coin can be tossed in two ways. Third coin can be tossed in two ways. Then three coins can be tossed one after other in m into n into p ways. That is 2 into 2 into 2, 2 cube ways. For n coins, 2 power n ways. Next slide. Throwing of a die experiment. Remember, one die is thrown. It can turn up on the ground. One die is thrown. It can turn up on the ground in two different ways. Sorry, 6 different ways. Two dice are thrown. Fundamental rule of counting. First die can turn up on the ground in 6 different ways. Second die can also turn up on the ground in 6 different ways. Then first die and second die can turn up on the ground one after other sequentially in m into n ways, 6 into 6 ways, 6 square ways. Similarly, 3 dice can turn up in 6 power 3 ways. మాట్లాడడం Similarly, n dice can be thrown in 6 power n ways. So theory completed. I need to solve the problems. If you want, I will give the break. Should I give the break? After the break, we'll do problems now. Students, tell me your opinions. If you want, I will continue. Yes, I will give the break. We'll continue after the break. After the break, we start problems. Till now, basics only completed. Yes, 15 minutes only break. 15 minutes only, not 20. Screenshot of Venn diagram. Okay. After the break, theory completed. Till now, basics only. Pooja, have you taken screenshot? $15 only break. Cards also, na? 1 minute. Anonymous attendee, if you say your name so that I can share. Cards. Pooja, have you taken? Okay, na? Next, anonymous attendee, if you say your name, I can share syllabus. Permutations screen. Take the screenshot immediately. Permutations, Anshu, wait. This is the first one. Second one. Yes, permutations only this is. Next. 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 If you have any doubts, we will Still anybody wants, at the end of the class, I will give you the screenshot. We will continue after the break. Welcome back, students. Problems. Problem number 1. Problem number 1. Write down. Two dice are rolled. Find the probability that sum is neither 8 nor 9. So sum is neither 8 nor 9. Do you know the meaning of neither 8 nor 9? Remember, neither A nor B means not A and not B. Not A. Not A means A complement, and means intersection, not B. Not B means B complement. Neither A nor B means A complement intersection B complement. Neither 8 nor 9. Neither 8 nor 9 means no 8 and no 9. First of all, two dice are thrown. So total cases 6 square is equal to 36. Now, favorable cases. If you have any doubt, Sai Krishna, please mention in question and answers. Now, let us see answer 3 by 4. Let us, this problem given in GATE Mechanical Engineering 2005. Let us see sum is equal to 8. Remember, sum of the dots on first and second die is equal to 8. Suppose a first die 1, second die 6. 1 plus 6 cannot be 8. Suppose a first die 2, second die 6. 2 plus 6 can be 8. Or first die 6, second die 2. 6 plus 2 can be 8. First die 3, second die 5. 3 plus 5 can be 8. First die 5, second die 3. 5 plus 3 can be 8. Now sum is equal to 9. Sum of the dots on two dice is equal to 9. First die 1, second die 6. 1 plus 6 cannot be 9. First die 2, second die 6. 2 plus 6 cannot be 9. First die 3, second die 6. 3 plus 6 can be 9. 4, 4 also 8. First die 4, second die 4. First die 6, second die 3. Next, first die 4, second die 5. First die 5, second die 4. So sum can be 9. So there are 5 cases favorable for sum is equal to 8. 4 cases favorable for sum is equal to 9. Next slide. Everyone, my humble request, take the screenshot. If anything you missed regarding the screenshot, at the end of the class, you ask me, I will share. Don't ask me in the middle. Or at the end of probability and statistics, entire chapter PDF notes also I will share you. Don't worry. But my humble request to follow me step by step. PDF notes also I can share. Neither sum is neither 8 nor 9. Neither 8 nor 9 means no 8. Neither 8 nor 9 means no 8 and no 9. No 8 and means intersection, no 9. No 9 means 9 complement. No 9 means 9 complement. And all of you observe De Morgan law. P of 8 union 9 whole complement. By De Morgan laws. Follow me step by step, everyone. So this is P of A complement. P of A complement formula 1 minus P of A. P of A complement is equal to 1 minus P of A formula I have applied. So 1 minus P of A union B formula P of A plus P of B minus P of A intersection B. Addition theorem. You only tell me if two dice are thrown, is it possible that sum of the dots on two dice is 8 and 9? Sum of the dots on two dice is 8 and 9. Not possible. Sum of the dots on two dice is 8 and 9. Not possible. Now 1 minus probability of how many cases favorable for sum is equal to 8. 5 cases. Total 36. How many cases favorable for sum is equal to 9? 4 cases. Total 36. So 1 minus 9 by 36. That is 1 minus 1 by 4. That is 3 by 4. Next. Problem number 2. Next slide. Next slide. Problem number 2. Write down. A die is rolled 4 times. Okay. Find the probability that problem number 1, sum is 22. Problem number 2, sum is 21. Sum 22, it was given in the gate computer science engineering 2014. First you copy the second problem, Sahiti. I will give you the screenshot. Let us continue. So everyone remember, a die is rolled 4 times. A die is thrown 1 time, total cases 6. Die thrown 2 times, 6 square. Die thrown 3 times, 6 cube. Die thrown 4 times, total cases. Follow me step by step, everyone. 6 to the power of 4. If you want, you can copy, no issue. Six power 4. What is 6 power 4? 1296. Good. Now we are checking the favorable cases for sum is equal to 22, and everyone should be carefully follow me step by step. We are writing sum is equal to 22 cases. Let us start from biggest number on the die. Biggest number on the die is 6. Take all sixes because a die is rolled 4 times. First die 6, second die 6, third die 6, fourth die 6. So 4 sixes are 24. But we need some 22 only. That's why you should not take 4 sixes. Then what you need to do is please take 3 sixes. For sum to be 22, one of the die has to turn up 4. 3 sixes are 18, 1 4 22. But one thing everyone has to remember that first die 6, second die 6, third die 6, fourth die 4. Now first die 6, second die 6, third die 4, fourth die 6. Now first die 6, second die 4, third die 6, fourth die 6. Now first die 4, second die 6, third die 6, fourth die 6. Here 4 at the fourth place, 4 at the third place, 4 at the second place, 4 at the first place. So with 3 sixes and 1 4, sum 22 can be generated 4 times. First die 6, second die 6, third die 6, fourth die 4. Like that, 22 can be generated 4 times. But every time writing possibilities in this manner will consume a lot of time. You should not do like that. Then you have to use Mississippi concept. Mississippi concept for sum 22. Sum 22, by mistake I have written sum 22. So Mississippi concept, instead of verifying 4 cases, apply Mississippi concept. Total how many elements? 1, 2, 3, 4. Total number of elements factorial in the numerator. Repeated elements in the denominator. 6 repeated 3 times, so 3 factorial. 4 factorial by 3 factorial, that is 4. 4 cases you have already seen. Next, I have tried with 3 sixes. Try with 2 sixes only now. Try with 2 sixes. Now 2 sixes are 12. For sum to be 22, already tried with 3 sixes. We are trying with 2 sixes now. 2 sixes are 12. For sum to be 22, the remaining 2 more dice should be 10. I mean sum. So 1 4 1 6. That's already completed earlier. So other possibility 2 5s. 2 5s are 10. 2 6 are 12. So use Mississippi concept. Repetitions, because 2 sixes and 2 5s. 2 sixes and 2 5s can occur in any order. 6 5 5 6 6 6 5 5 5 6 5 6. 2 sixes and 2 5s can occur in any order. Means first die 6, second die 6, third die 4, 5, fourth die 5. Or first die 5, second die 6. Like that, different possibilities. That's why Mississippi concept. Total 4 elements. Denominator only repeated elements. 6 repeated 2 times, 2 factorial. 5 repeated 2 times, 2 factorial. So therefore, answer 6 only. I have tried with 3 sixes. I tried with 2 sixes. Let me try with 1 6. Possible? Use only 1 6. If you are using only 1 6, then you should go to the next biggest number on the die. Next biggest number on the die is 5. Take all 5s. 3 5s are 15 plus 6, 21. So with 1 6, sum 22 cannot be generated. Therefore, stop here. Therefore, probability is equal to favorable cases by total cases. Favorable cases 4 plus 6, 10, by total cases 1296. I am going to the next slide. This is the first case. Follow me step by step. Next, now we are checking sum is equal to 21. Let us start from biggest number on the die, 6. Take for all dice 6. 4 6s are 24. So 4 dice should not take 6s. Now you take 3 dice 6, 1 for sum to be 21. One of the dice should turn up as 3. Now how many cases? Mississippi concept. First die 6, second die 6, third die 6, fourth die 3. Next to first die 3, second die 6, third die 6, fourth die 6. In this manner, we have different combinations. In such cases, directly apply the example of Mississippi. Total 4 elements. So numerator 4 factorial. Denominator only repeated elements. 6 repeated 3 times 3 factorial. So answer is 4. Next I have tried with 3 sixes. Now try with 2 sixes only. Tell me, for sum to be 21, already 2 sixes are 12. For sum to be 21, remaining 2 more dice, sum should be 9. 2 more dice, sum should be 9 means 1 die 4, 1 die 5. 21. Total number of elements 4. 4 factorial, 6 repeated 2 times, 2 factorial. Answer 4 threes are 12. I have tried with 3 sixes, tried with 2 sixes, try with 1 6. For sum to be 1 6 only, not more than that. For sum to be 21, the remaining 3 more dice sum should be 15. Tell me, you have to choose 1 6 only. The remaining 3 more dice must be 5s. 3 5s are 21. Sorry, 3 5s are 15 plus 6, 21. Total number of elements 4. 4 factorial. 5 repeated 3 times 3 factorial. The answer should be 4. So without using 6, can you generate some 21? No. 4 5s are 20 only. Without using 6 means next biggest number 5. 4 5s are 20. 21 not possible. Then stop. Probability is equal to, count how many cases favorable. 4 plus 12 plus 4, 20. Total 1296. Note this problem and try yourself. When you throw three fair dice, comma, the probability that the sum of the numbers on the top faces is 10 is answer 27 by 216, answer 0.125. Try yourself it later. I go to the next slide. Write down. Okay, you don't want answers. If you don't want answers, you may get confused. Take answers and try to get. Otherwise, I don't give. No issue. 3 integers are
Dear students, wait for a few minutes due to electricity problem. Sir has went away. Wait for 5 minutes. Dear students, wait for 5 minutes.
Sorry, there is a disconnection. Welcome back. So write down 3 integers are chosen at random without replacement from this set from this set 1, 2, 3, 4, 5, so on 10. The probability that their product is even is you are given 20 natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. Out of 20 numbers, 3 numbers has out of 20, 3 numbers are selected at random.
Sir,
Venkat.
అది మెటీరియల్ అప్లోడ్ చేశాను, డౌన్లోడ్ చేసుకోమన్నాను సార్.
అలాగే okay. So material has been uploaded. You can download that material and I will teach that material problems and some other questions also along with that previous gate and some other competitive exam papers. The probability that their product is even. Out of 20 numbers, 3 numbers are selected at random. So total cases for selection of 3 numbers out of 20 will be 20C3. What is the value of 20C3? 20 factorial by 3 factorial into 17 factorial. That is 20 into 19 into 18. Simplify and tell me the value of 20C3. 20C3 value. Simplify and tell me. Now listen to me, everyone. Everyone, please listen to me. First of all, I will not find the product of out of 1140. Correct. 1140. First listen to me, all of you. First of all, 3 numbers are selected. What is the probability that the product of 3 numbers is even? Remember everyone, product of 3 numbers is even only when one of them is even number, or 2 of them are even numbers, or 3 of them are even numbers. That means 1 is even, or 2 are even, or 3 are even. So you need to discuss 3 cases. It will consume time. So that's why probability of product is even is equal to 1 minus probability of product is odd. So product of 3 numbers is odd only when all 3 numbers are odd numbers only. So this is easy. So from 1 to 20, we have 10 odd numbers and 10 even numbers. So out of 20 numbers, 3 numbers are selected at random. So that is total cases 20 C3. So the selected 3 numbers must be odd numbers. Then only the product of 3 numbers is odd only when all 3 numbers are odd numbers only. So product is odd only when the selected 3 numbers are odd. Then only product will be odd. So if the selected 3 numbers are odd, from 1 to 20, we have 10 even numbers, 10 odd numbers. Therefore, these 3 odd numbers have been chosen from 10 odd numbers. So selection of 3 odd numbers out of 10 odd numbers is 10C3. This is the probability of product is odd. Product is even means 1 minus this value. That's it. Simple only. Go back and see. Now, write down. First, let us find product is even. Let us find product is even, means product is odd. Let A is equal to product is odd and A complement is equal to product is even. Now write down. Out of 1, 2, 3, so on, 20, means out of first 20 natural numbers, we have 10 odd integers and 10 even integers. So now I'm going to the next slide. Favorable cases for product is odd. Write down. In the exam, this detailed explanation not required. Directly you write briefly. Favorable cases for product is odd. Remember, product of 3 numbers is odd only when all 3 numbers are odd numbers only. Therefore, out of 20 numbers, we have 10 odd integers and 10 even integers. The selected 3 numbers are odd. These 3 odd numbers will be chosen from 10 odd numbers. So selection of 3 odd numbers out of 10 odd numbers from 1, 2, 3, so on 20 is 10C3. So what is the value of 10C3? What is the value of 10C3? 120. Now P of A. P of A means probability of product is odd. Probability of product is odd. Favorable cases 120, total cases 1140. What is this value? What is this value? 2 by 19. Now, therefore, 2 by 19, good. Now, therefore, P of A complement is equal to 1 minus P of A. That is 1 minus P of A means 1 minus 2 by 19. That is 17 by 19. No, 120. Please verify. And next. Next problem. Write down. Consider without replacement means out of 10 numbers, out of 20 numbers, 3 numbers are chosen at a time and those 3 numbers are not replaced. Remember, with replacement, without replacement, no issue. Whenever the problem is mentioned one after other, whenever the problem mentioned one after other, then only with replacement or without replacement will have meaningful. One after other is not mentioned, with or without replacement will not have any meaning. Write down. Consider a biased coin that comes up heads with probability 1 by 3 and tails with probability 2 by 3. Full stop. If the coin is tossed see, biased coin means the chances of head and tail are 50-50. Probability of head is equal to probability of tail. That is unbiased coin. Biased coin means probability of occurrence of head is not equal to probability of occurrence of tail. Means probability of head will not be 1 by 2. Probability of tail will not be 1 by 2 in case of biased coin. Fair coin or unbiased coin meaning same. A die is thrown, the chances of occurrences of all events are equally likely 1 by 6, 1 by 6, 1 by 6. Unfair coin or unfair die or biased coin means the chances of heads and tails will not be equally likely. Probability of head will not be 1 by 2. Tail will not be 1 by 2. Probability of die showing number 1 will not be 1 by 6. It is different. With or without replacement. With replacement, without replacement, no change. Only problem they mention one after other. Then only with or without replacement will change the answer. One after other is not mentioned, no change. Please concentrate here first. You are continuously asking then how the class will go. If the coin is tossed 2n times, then the probability that at some time during this experiment two consecutive means sequential, two consecutive coin flips, flips means tosses, come up both heads or both tails is. I am going to the next slide. Remember, a biased coin that comes up heads with probability 1 by 2 and tails with probability and tails, here and is there, and tails with probability 2 by 3. Suppose the coin is tossed 2n times. What is the probability that two consecutive tosses come up both heads or both tails? Two consecutive tosses will show both heads or both tails. Option A, 3 power n minus 2 to the power of n by 3 power 2n. Option B, 3 power 2n minus 2 power n plus 1 by 3 power 2n. Option C, 3 power n plus 1 minus 2 to the power of n by 3 power 2n. Option D, 3 power n plus 2 to the power of n plus 1 by 3 power 2n. Remember, if you solve the problem as per the procedure, it will become lengthy. So that's why my sincere suggestion, please do solve like this. First, given information, probability of head 1 by 3, probability of tail they give 2 by 3. Please concentrate here. That means, should not I solve? You only have to you only solve. Harish, Harsha, will you solve yourself? But all types of students are there. You are asking 1 or 2 minutes time to solve. That's why I'm asking. To solve or to copy? You are asking, I don't know. Okay, listen to me. If you solve the problem as per the procedure, it will consume time. Please focus here on, without focusing on unnecessary things, Focus on the solution. So coin is tossed 2n times. 2n times. Look, I will solve the problem by choosing n is equal to 1. They said coin tossed 2n times. If I take n is equal to 1, it would be 2 times. Be careful, all of you, what I am saying. They said coin is tossed 2n times. If I take n is equal to 1, coin tossed 2 times only. 2 times only. So in these two tosses, what is the probability that two consecutive flips, flips means tosses, two consecutive flips showing both heads or both tails, two consecutive, two sequential heads or two sequential tails? Tell me, we want probability of two consecutive flips both heads. In the exam, you need not write this theory. Directly simplified form you write. Both heads or both tails. Two consecutive heads or two consecutive tails. Means what? Two sequential heads. HH. R. R means what? Plus. R means plus. Two consecutive tails means two sequential tails. Now please focus. HH. H value 1 by 3, H value 1 by 3. So therefore it is 1 by 3 whole square. Tail, tail. T value 2 by 3, T value 2 by 3. That is 2 by 3 whole square. So this is 1 by 9 plus 4 by 9. This is 1 by 9 plus 4 by 9. Answer. This is the easiest way to verify without solving the problem in lengthy manner. Directly we can solve. It will consume time also. Look here. Answer 5 by 9. Among 4 options, which option will show 5 by 9 by taking n is equal to 1 is the answer? Option B correct. Look here, I took n is equal to 1. Among 4 options, which option will give you 5 by 9 by choosing n is equal to 1? That is the right answer. Look, if I take n is equal to 1 in option A, 3 power 1 minus 2 power 1 by 3 power 2 square. That is 1 by 9. So option A wrong. Please focus here. Now if I take n is equal to 1 in option B, 3 power 2 minus 2 power 1 plus 1, 2 by 3 power 2. This is 9 minus 4, 5 by 9. So with option B, we got 5 by 9. So option B is the right answer. If you have a doubt, verify with option C also. If I take n is equal to 1 in option C, 3 power 1 plus 1, 2 minus 2 power 1 by 3 power 2 into 1, 9 minus 4, 3 power 1 plus 1, 9 minus 2, 7 by 9. It is not matching. So option C wrong. This is the way you people have to cross check. This one student asked me why you have taken n is equal to 1. My humble request, please read the question. Coin tossed 2n times. If you solve the problem by writing 2n times, it becomes lengthy. That's why take n is equal to 1 here. If I take n is equal to 1, coin tossed 2 times. Or take n is equal to 2, coin tossed 2 2s are 4 times. Take n is equal to 3, coin tossed 2 3s are 6 times. I solved only for n is equal to 1. Coin tossed 2 times. Question not understood. Humble request to everybody. Please look. Everyone, listen to me. A coin is tossed 2n times. If one coin is biased coin means you are asking again same and same. Biased coin means unbiased coin means a coin is tossed, probability of head 1 by 2, probability of tail 1 by 2. Biased coin means probability of head is different from probability of tail, means both will not be same. Biased coin means same time when you toss a coin, chances of head and tail are same, equally likely. But biased coin means if a coin is tossed, frequently we get head only or frequently we get tail only. That is biased coin. Every time we will not get, there is no equal chance of head or tail. Frequently we get head or frequently we get tail. One student did not understand the problem. Please, student, listen to me. Probability of coin showing head with biased coin is 1 by 3. Given probability of coin showing tail with biased coin is 2 by 3. If you toss a coin 2n times, what is the probability that two consecutive coin flips? Two consecutive coin flips means two sequential coin flips. Two consecutive means two sequential coin tosses. Two coin tosses will show both heads. Two coin tosses will show both heads or both tails. Two consecutive tosses, both heads or both tails. But here coin tossed 2n times. 2n times is lengthy. So take n is equal to 1, 2. So n is equal to 1, 2. That means coin tossed 2 times. We need two sequential heads or two sequential tails. Two sequential heads, two sequential tails. Probability of head 1 by 3. Probability of head 1 by 3. 1 by 3 into 1 by 3. 1 by 9. 2 by 3 into 2 by 3. 2 by 9. General method will take lot of time, Mr. Manoj. If you want, at the end of the class, I will show you. In the exam, if I solve in traditional method, it will consume. If you want at the end of the class, please ask me. I will tell you your general method also. Next problem. Anyone, if you want more information daily at the end of the class, remind me. I will explain everything. Class should go smoothly. For that, your cooperation is required. And at the same time, you people have to understand also. Understanding and cooperation, both are essential. Right now. Next problem. Write down. Still, anybody wants more information or general method also, I will explain. At the end of the class, you ask the probability that a person, please write here. Third question means so far I have written. You are asking third question screenshot. Because class should not go smooth. Cooperation is important. Everyone follow me step by step. Now, everyone, don't ask me screenshots. If anybody wants screenshot at the end of the class, ask me, I will share. At the end of the probability also, PDF notes I will give you. Humble request, follow me step by step. The probability that a person will get an electric contract is 2/5 and the probability that he will not get plumbing contract is 4/7. Write down if the probability of getting at least one contract is 2/3. Then the probability that he will get both the contracts is option A 17/105, option B 3/7, option C 4/7, remember everyone, probability of person getting electric contract, probability of person getting electric contract is 2/5. Did you copy? Now probability of person will not get a plumbing contract. Person will not get a plumbing contract means P complement. Yes, option A correct. Srujana correct. So probability of person will not get plumbing contract is 4/7. Will not get plumbing contract means P complement. So P of P complement is 4/7. Then P of P is 1 minus P of P complement. 1 minus 4/7, 3/7. And all of you, at least one, do you know the meaning of A union B? And all of you look here, A union B formula, A or B or both or at least one. A union B formula, A or B or both or at least one. Here we were given 2/3 probability of getting at least one contract. At least one means A union B formula only. A union B means A or B or both or at least one. Probability of getting at least one contract means A union B. A means E union P, electric contract union plumbing contract. You are asked to find the probability of getting both contracts. Both contracts means E intersection P. E electric contract and plumbing contract means E intersection P. We need to find. Write down the formula. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So P of E union P 2/3, P of E 2/5, P of P 3/7 minus P of E intersection P. So P of E intersection P is equal to 2/5 plus 3/7 minus 2/3. Take LCM 573, LCM 105. 5 sevens are 35, 35 threes are 105, 105. 5 21s are 105, 21 into 2, 42. 7 15s are 105, 15 threes are 45. 3 35s are 105, 35 twos are 70. 47 87, that is 17/105. Option A, very good all of you. I will go to the next slide. Please make it right now. Next slide. An integer selected at random between 1 and 1000 within the brackets. Previous slide. Gopinath, at least one. At least one means what? I told already. At least one. At least means greater than or equal to. At least one means greater than or equal to 1. We have two events, say E and P. At least one means what? Greater than or equal to 1. Means one or more. One or more means what? 1. E. R means union. More means P. One or greater than or equal to 1 means one or more. We have two events only, E and P. One or more means one or more. More means another one. At least one meaning A union B only. Both inclusive. Write down. Concentrate here first. If you have doubts, will be clarified. It is one or more. One or more. One or more means what? A union B. One more minus A union B, one or more only. It is including one. A union B means 1 plus 2. find the probability that not only one or more means 1 plus 2 also. Find the probability that is not divisible by 12 or 15 is. Remember, some of the questions in the examination are fill in the blank questions also. Every fill in the blank question in the exam is a numerical answer type, means answer some numerical value. You are asked to find one number. One number is selected at random from 1000 numbers. So selecting one number out of 1000 numbers is 1000 C1, means 1000. What is the probability that selected number not divisible by 12 or 15? So first let us find selected number is divisible by 12 or 15. A union B, selected number is divisible by 12 or R means union 15. Selected number divisible by 12, R means union 15. Divisible by 12 or 15, I will find first. Next, I will find not divisible by 12 or 15. This is, we are finding divisible by 12 or 15. R means union. This is P of A union B formula. Note down. P of A plus P of B minus P of and everyone listen to me carefully. Yes, 0.867 correct. And all of you listen, whenever you want to know how many numbers divisible by 12, how many numbers divisible by 12, simply identify from 1 to 1000. From 1 to 1000, what is the last number that is exactly divisible by 12? You want to know how many numbers divisible by 12? All 12 multiples are divisible by 12. 12, 24, 36, 48, 60 like that. But counting in this manner will consume time. That's why simply from 1 to 100, 1 to 1000, identify what is the last number that is exactly divisible by inclusive. Both inclusive means including 1 and 1000, including 1 and 1000. From 1 to 1000, what is the last number that is exactly divisible by 12? 996. This you need to identify. Divide this 996 by 12. Answer 83. That means from 1 to 1000, we have 83 numbers are there which are exactly divisible by 12. Those 83 numbers are 12 multiples of 12, 24, 36, 48. Like that, 83 numbers are there. Now, from 1 to 1000, you want to know the numbers which are divisible by 15. You just need to identify 15 multiples. 15, 30, 45. Counting in this manner will consume lot of time. That's why from 1 to 1000, you identify the last number that is exactly divisible by 15. 1 to 1000, last number exactly divisible by 15 is 990. Divide that 990 by 15. Answer 66. That means from 1 to 0.867. From 1 to 1000, there are 66 numbers which are exactly divisible by 15. Those 66 numbers are 15, 30, 45, so on. And all of you, everyone careful, whenever you want to know how many numbers which are divisible by 12 and 15, you need to take LCM of 12 and 15. LCM of 12 and 15 is 60. Please verify. LCM of 12 and 15 is 60. Whenever you want to know how many numbers which are divisible by 12 and 15, means 2 or more than 2 numbers, take LCM of those 2 or more than 2 numbers. LCM of 12 and 15, 60. So the numbers which are divisible by 60 will automatically divisible by 12 and 15, because 12 and 15 LCM 60. From 1 to 1000, what is the last number that is exactly divisible by 60? You need to identify 60, 960. Divide that 960 by 60. Answer 16. Now come back. Favorable cases for the selected number divisible by 12, 83, total 1000. Favorable cases for the selected number divisible by 15, 66, total 1000. Favorable cases for the selected number divisible by 12 and 15, 16, total 1000. Count this, and what is the answer? 66 minus 6, 60 minus 10, 50. 50 plus 83, 133. 0.133. Good. Now this is the probability of selected number divisible by 12 or 15. But we want selected number not divisible by 12 or 15. Now probability of selected number not divisible by 12 or 15. Selected number not divisible by 12 or 15, that is 1 minus 12 union 15. The answer is 1 minus, you said this is 0.133. 1 minus 0.133. Tell me the answer. 0.866. 0.86666 means 0.867. This is the answer. 0.866 or 0.867. Similarly, note this and try yourself. A natural number, 1 minute. A number is selected at random from first to 200 natural numbers. The probability that it is not divisible by 6 or 8 is dash. Note down. Answer 0.75. Try yourself it later. Next. Okay, na? Good. Note down. Next problem. Let A and B be events. Seventh question answer 0.866. 0.866. Let A and B are be events in a sample space. Yes. Concentrate here. I'm not writing anything fast. Instead of writing everything. Why you are worrying, man? At the end of the class, whatever you want, your doubts, your screenshots, your PDF notes, everything will be given. First, right? Everything will be given. Just sitting and typing the messages very easy. Don't take the advantage. Concentrate on continuation of class. It should go smooth. Everything will be shared, man. No doubt. P of A is equal to. My humble request to everybody, man. You are sitting at home and opening the video and writing. Please concentrate on content. Whatever you want, I will provide. Why you are worrying? From the beginning also, if you want, I can. But my request, concentrate here first. Everything will be given. Whatever you miss will be given. But first note, because your 50% concentration being diverted just because of typing unnecessary things. I said at the end of the session also, if you want, I will give PDF notes or any screenshots I will give, but focus. I don't find. I'm going to the next slide. Next slide. P of A union B complement. Second one, P of A complement union B complement. I have already no raising hands in the middle. At the end of the class, only raise your hands. Meanwhile, in the middle, anything which is important, please enter in question and answers. I will answer. But don't worry, every doubt will be clarified. If you cannot understand anything, it will be clarified. So note down. Did you write? P of A value 1 by 2, P of B value 1 by 2, A complement intersection B complement 1 by 3. Then you are asked to find these values. So first to write the given information. P of A value, P of B value 1 by 2. Now you are also given, concentrate on the subject, P of A complement intersection B complement is equal to 1 by 3. Everything will be given, focus on the concept, content. A complement intersection B complement, that is A union B whole complement. This is De Morgan laws. I have already given De Morgan laws. A complement intersection B complement, first to De Morgan law. A union B whole complement. This is 1 minus P of A union B. This is P of E complement is equal to 1 minus P of E. This is the formula I applied. From this, 1 minus P of A union B formula, P of A plus P of B minus P of A intersection B is equal to 1 by 3. P of A 1 by 2, P of B 1 by 2 minus P of A intersection B value don't know. Look here, 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2, 1. Minus into 1, minus 1. Minus 1 plus 1 cancel. So still you have minus into minus. Still you have minus into minus plus. Plus P of A intersection B plus into P of A intersection B is equal to 1 by 3. Plus into P of A intersection B is equal to 1 by 3. 1 by 2 plus 1 by 2, 1. 1 minus 1, 1. Minus into minus plus. P of A intersection B is 1 by 3. Now you are asked to find question number 1. P of A union B complement. Yes, no. Tirth Jain, please verify. P of A union B complement, assume it as P of A union B. P of A union B formula, P of A plus P of B means P of B complement minus P of A intersection B. And I don't know whether you people remembered or not. I have already given the Venn diagram of A intersection B complement. A intersection B complement Venn diagram was already given. And all of you look here. A intersection B complement means area occupied by circle B. B complement means area occupied by circle B is deleted completely. A intersection B complement means area occupied by circle B is deleted completely and the remaining area in circle A is considered. This A intersection B complement is equal to A intersection B complement is equal to total area inside circle A minus A intersection B. P of A as it is. P of B complement means 1 minus P of B. P of A intersection B complement is equal to P of A minus P of A intersection B. P of A minus P of A intersection B. Substitute. P of A value 1 by 2. 1 minus P of B. P of B 1 by 2 minus P of A value 1 by 2. Here P of A intersection B 1 by 3. This is 1 by 2 plus 1 by 2 minus 1 by 2 minus into minus plus 1 by 3. Plus 1 by 2 minus 1 by 2 cancel. 1 by 2 plus 1 by 3 5 by 6. Second problem direct step. All of you, second problem direct step. Very good. 5 by 6 is very good. Direct step. Solve the first problem. First problem I gave. Second problem very easy. Try yourself. Second problem answer 2 by 3. All of you. Second problem answer 2 by 3. Second problem answer 2 by 3. Try yourself. Second problem answer 2 by 3. Very good. Madhavi, Soni, where did I forget? You forgot plus 1. Where? In the first problem, 1 minus P of A. Everything is fine. 1 by 2 plus 1 by 3. Correct, Madhavi? Please verify. Second problem, very easy. Try yourself. Just 1 minute, 5 minutes. We'll stop. Note one more problem. After 5 minutes, we will stop, students. Intersection of B complement. B complement, you should not write A minus B. B complement, you should not write A minus B. Harsha, B complement should not be written as A minus B. B complement means the total remaining area, A and outside. Write down. If 7 car accidents, 5 minutes. If 7 car accidents occurred in a week, comma, What is the probability that just 5 minutes? All accidents occur on the same day of week. No two accidents occur on the same day of week. The first problem given in GATE computer science engineering. Okay, you want to try yourself? You can try. I will give one more. Try yourself and I will give one more. I will give the answers. First problem answer 1 by 7 power 6. Six factorial by 7 power 6. Similarly, note this problem and try yourself. I'll stop. Just note this question. I stop. A deck of 5 cards each carrying a distinct means a different number from 1 to 5. Just note this, will stop. Is shuffled thoroughly. Two cards are removed. Two cards are then removed from the deck. One at a time. One time, one card only. What is the probability that I'm going to the next slide? The two cards are selected. the two cards are selected with I'm going to the next slide. With the number of first card next slide. With the number of first card being one higher than the number on the second card, GATE Computer Science Engineering 2011. If you have doubts, you can ask me now. You only asked, that's why, otherwise I will explain. Don't worry, if you are unable to solve, I will teach the problems. Don't worry, I will explain everything. And doubts you can ask me, I will permit them. Harsha, do you hear me?
Hello, am I audible, sir?
Tell me. Audible.
Sir, my doubt is, can I write A intersection B complement as A minus B?
A intersection B complement. Fine. This is A minus B.
Sir, so in previous question, I applied this, but I'm not getting the answer, sir.
Because listen to me, A intersection B complement means A minus B wrong. Look here, this is wrong. A intersection B complement. B complement means what? This is A intersection B complement. This cannot be written as A minus B. This is written as A minus A intersection B. Remember, A intersection B complement cannot be written as A minus B.
But sir, the portion you shown by A intersection B complement is same as A minus B, na sir?
A minus B. This is A minus B. A minus B means what? Total area inside A minus total area inside B. Total area A minus B means what? Total area inside A minus total area inside B. If you remove total area inside B, but you are not getting total area inside A, still A intersection B part is missing, no? A minus B, A intersection B complement, how will it be A minus B? Capital A minus capital B means total area inside A minus total area inside B.
Okay, sir.
So see, listen, these are dependent events. How can you write dependent events like that?
Okay, sir.
Any other?
No, sir. Thank you.
Next. Madhavi Soni, do you hear me?
Yes, good afternoon, sir.
Good afternoon. Tell me.
Sir, in question number 9.
1 minute. Question number
9.
9.
The first one which we solved. P of A union B complement. Sir, there in one step I written in question.
That's why I'm asking, if you know the Venn diagram of A union B complement, it's very easy to answer. That's why I said no. A union B complement diagram.
Yes, I got that in the solution which we have solved. Then I guess we have missed one step, sir. We have written B complement as 1 minus P of B.
Where?
Same first one, first one which we have solved.
This is A union B complement.
No, sir, below. Just scroll down.
Next one.
Yes,
A union B complement.
Yes, sir. In fourth step, we have taken 1 by 2.
1 minute. 1 by 2. Okay. 1 minus 1 by 2 is 1 by 2.
Okay.
1 minus 1 by 2 is 1 by 2. Minus into 1 by 2. Minus into minus plus 1 by 3.
Got it, sir.
Okay. Any other?
No, sir. No. Thank you.
Okay, fine. Next. Akshay. Akshay Shet, tell me. Do you hear me? Akshay, do you hear me?
Yes, sir.
Tell me.
Sir, in that repetitive question, like in Mississippi questions, same question, you took 5 mangoes. In that question.
Which one? Ninth one, huh?
No, ninth one, no, sir. Not. The
Question number.
Question that.
Problem number.
No, there is no problem number, sir. Sir, you took example abracadabra. That question.
Which one? Please read the question.
Sir, how many arrangements are possible in abracadabra? That question.
Okay, 1 minute. This one, huh? This one, huh?
Sir, the question before that, you took the combination of 5 A's, 5 B's. That question.
5A. This one, huh? Problems or theory? The problems from here.
It is from theory. It is from theory, sir.
Okay. This one, huh? This one, huh?
Sir, before that, the question before that.
This one, huh?
Yes, sir. Yes, sir. This
tell me.
Sir, here you took 17 factorial. Instead of it should be 20 factorial, right? Because we all found
1 minute. 2. Total how many elements? Total how many elements?
17.
Total 17 elements. So it should be 17 factorial, no?
So actually, I asked you a question that you told that only repetitive elements should.
Listen to me. Numerator, total number of elements factorial.
Okay, sir. Got it.
Denominator, A repeated 2 times 2 factorial, B repeated 3 times 3 factorial, C repeated 4 times 4 factorial, D repeated 5 times 5 factorial, E repeated 1 time 1 factorial. Non-repeated not required. 1 factorial will not change.
Okay, sir.
Any other?
No, sir. Thank you.
Okay, fine. Next. Shravika.
Hello,
do
sir.
You hear? Tell me. Good afternoon.
Question number 4, the problem part, sir. Question number 4. 3 integers are chosen at random without replacement.
Question number? Fine.
Sir, in that question, if we take 2 odd numbers and 1 even number, then also the sum will be even, no, sir?
I'm not asking sum. Product, no, they said, not sum.
Yes, sir. Oh, sorry. Product only, sir. 2 odd and 1 even.
2 odd, 1 even. So, okay, 1 minute. Listen to me. 2 odd numbers, 3 and 5. 3 5s are how much?
Yes,
15. 1 even number 2. 15 2s are 30. 30 even number, no?
Yes, sir.
3 odd numbers. So 7090. 7090 63. 7 9s are 63. 1 even number 2. 63 2s are 126. Even number, no?
Yes, sir.
See, product of two odd numbers is odd only when two numbers must be odd. Product of three odd numbers is odd only when 3 are odd. All are odd, then only its product should be odd. Otherwise, not possible.
But in question they're asking even, no, sir.
That's why I'm asking. That's why what I didn't find even. First I find product is odd. Look, first I find A. A means what? Product is odd. First I find product is odd. Next to A complement means what? Product is even. First I found.
Product is even. Yes.
So product is odd I found. Next to 1 minus product is odd is product is even. Product of three numbers is even only when 1 is even, or 2 are even, or 3 are even.
Yes, sir.
Product of three numbers is even only when one of them is even number, or 2 of them are even numbers, or 3 of them are even numbers.
Yes, sir.
So that's why it is lengthy. 3 cases we need to discuss. That's why each case I found. That's why I found product is odd.
So, sir, in this also all cases are covered, no, sir?
No, I found product is odd only. 1 minus product is odd is even. If you want, you have to find, look, if you want, you can find like this. 1 is even number, 2 odd numbers, or 2 even number, 1 odd number, or 3 even numbers. 1 even, 2 odd, 2 even, 1 odd, 3 even. This case you need to find separately. 1 even, 10C1, 2 odd, 10C2. Here 2 even, 10C2 into 10C1 plus 3 even, 10C3. By add all these by 20C3, you will get the same answer.
Okay.
Product is even, 1 is even, 2 are odd, or 2 even, 1 odd, or 3 even. Correct or not? Got it or not?
Yes, I understood.
Understood?
Yes, sir. I was thinking of first and 2 cases. So
No, 3 are even also even of product.
Yes, sir.
Okay, na?
Yeah, yes, sir.
Okay, any other?
No, sir. Only this.
Okay, fine. And next, Tirth Jain.
Hello.
Tell me.
Good afternoon, sir.
Good afternoon.
So, P of A union B dash.
P of A union
B dash.
Only B complement.
Yes. Equal to.
Is equal to
1 minus P of B.
1 minus
P of B.
P of B
Plus.
Plus
P of A intersection B.
P of A. Yes, actually A union B complement Venn diagram. What is A union B complement Venn diagram? A union B complement Venn diagram means what?
Whole A and B of.
That is correct only what you said. From the Venn diagram only.
So if we solve question number 9 by this, then answer is different.
1 minute. A union B complement. What is the Venn diagram of A union B complement? This is A, this is B. A union B complement means what? This is A union B complement.
So here we have to first
listen. A union B complement means what? P of A intersection B. Sorry, P of A intersection B complement plus P of A complement intersection B complement. Check the diagram. I have already given A complement intersection B complement. A complement intersection B complement means what? This outside, this is A intersection B complement,
Yes, sir.
plus B complement means what? Only total area inside B is deleted. Then this remaining part is also there. This remaining part, A intersection B complement.
Okay, sir.
Plus this outside two circles, A complement intersection B complement. By adding both, you will get.
Okay, sir.
You understand or not? Any
Yes,
ambiguity, doubt?
No, sir. I understand.
Okay. Any other?
No, sir. Thank you, sir.
Fine, fine. Next. Sai Kiran. Sai Kiran.
Can you hear me?
Yes, yes.
Hello,
yes.
sir. Good afternoon, sir.
Good afternoon. Audible.
Sir, in the problem, sir, in the problem we took biased coin, no, sir. That problem, sir. Sir, ఆ ప్రాబ్లం లో శాంపిల్ స్పేస్ 2 పవర్ అదే 3
ప్రాబ్లం
పవర్
చెప్పు, ప్రాబ్లం చెప్పు, చెప్తాను. ప్రాబ్లం నంబర్ ఎంత?
ప్రాబ్లం నంబర్ గుర్తులేదు. ఇదే అదే సార్.
ఇదే కదా ప్రాబ్లం నంబర్ 5. అందుకే ప్రాబ్లమ్స్ ఇచ్చాను. ఆ డౌట్ ఏంటి చెప్పు. ఏం అర్థం కాలేదో చెప్తే అన్ని
ట్రై చేసి మామూలు అర్థమైంది సార్. అందులో శాంపిల్ స్పేస్ కింద ఆప్షన్స్ లో ఇచ్చాడు 3 పవర్. బయాస్డ్ కాయిన్ కి శాంపిల్ స్పేస్ ఎలా తీసుకుందాం
అంటే ఈ 2n ఈ ప్రాబిలిటీతో తీసుకోవచ్చు కదా. ఈ ప్రాబిలిటీతో 1/3 2/3 కాయిన్ టాస్ 2n టైమ్స్ కదా. ఇప్పుడు కాయిన్ టాస్డ్, ఇప్పుడు నువ్వు హెడ్స్ కే రాయి. ప్రాబిలిటీ ఏంటి? ఇప్పుడు ప్రాబిలిటీ ఆఫ్
1/2.
ఇప్పుడు 1/3 ఇక్కడ హెడ్స్ కే. ఇప్పుడు డినామినేటర్ 3 కదా. డినామినేటర్ 3 అంటే ఏంటి? ఇప్పుడు కాయిన్ 2n టైమ్స్ టాస్ చేసాడు, అంతేనా? ఇప్పుడు
అంతే సార్.
ఇప్పుడు టోటల్ నంబర్ ఆఫ్ ఎలా ఉన్నా సరే కాయిన్ 2 సైడ్స్. ఇప్పుడు కాయిన్ ఎగరేసామనుకో హెడ్ ఆర్ టెయిల్ వస్తాయి, అంతేనా? ఇక్కడ నేనేం చెప్పాను? 1/3 2/3.
yes sir, 1/3 2/3.
అంటే దాని అర్థం ఏంటి? కాయిన్ 3 ఒకసారి ఎగరేస్తే 3 పవర్ 1 కదా, 3 పవర్ 2 3 పవర్ 3 కదా. ఇప్పుడు కాయిన్ ఒక సైడ్ హెడ్ ఒక సైడ్ టెయిల్ అయితే ఏంటి? 2 పవర్ 1 1 కదా. 1 హెడ్ 1 టెయిల్.
yes sir
2 పవర్ 1 2 పవర్ 2. ఇదేంటి? 3 పవర్ 1 3 పవర్ 2 3 పవర్ 3 ఇలా వస్తుంది.
yes sir, అర్థమైంది సార్.
అర్థమైందా? క్లియర్ గా చెప్పాలా?
yes sir, అర్థమైంది సార్.
ఓకే ఓకే. అంటే 1:2 రేషియోలో ఉన్నాయి ఇక్కడ. అక్కడేమో 1/3 2/3 అంటే 1:2 రేషియో. అక్కడేమో 1:1 రేషియో.
ఇక్కడ 1:2
రేషియో డిఫరెంట్.
సార్ థ్యాంక్ యూ సార్. అంతే సార్.
ఓకే ఓకే. నెక్స్ట్ సాహితి.
So good afternoon, sir.
Good afternoon, Amma. Tell me.
So 6th question, sir.
Problem number
6.
Chipam. Tell me.
Sir, in that question, if the probability of getting at least one means you said that we need to consider E union P.
Listen.
So,
A union. Okay. What is the meaning of at least? At least
one or more.
One. At least means
yes,
greater than or equal to 1. One or
yes,
more. So
yes,
at least one means what? Total how many events are there? E and P.
Yes, sir.
See, probability of E. Okay, na? Oh, sorry, 1 minute. Listen to me.
Yes,
one or more, no? That means what?
Yes, sir.
Electric contract and no plumbing contract. Correct?
Yes, sir.
Only one. This is one or more means only one. This is only one. First I am writing
okay,
one cases. Only one cases. Electric contract and no plumbing contract. Now
and no plumbing.
No electric contract and a plumbing contract. This is one case.
Okay, sir.
Only one case. Now 2 cases are electric contract and a plumbing contract. Add all, you will get the required answer.
Okay.
Understood,
sir. Yes, sir. And probability that he will get both the contracts means that is intersection, sir.
Yes, both the contracts means probability.
So can you show that using a Venn diagram?
Which one you want me to show so that
This sentence, a probability that he'll get both the contracts.
Look, this is the in Venn diagram. This is E, this is P. E intersection P complement means what? This is E intersection P.
Yes, sir.
Both the contracts means electric contract and plumbing contract. What is this? And this is E intersection P complement.
Yes,
this,
sir. Intersection P.
E intersection P complement means.
P complement.
This is blue colored area is E complement intersection P.
Yes, sir.
By adding all, you will get P of E union P.
Yes, sir.
Correct or not?
Yes, sir.
Any doubt regarding this? Ask me, no issue.
No, sir. No, sir. I understood. Sir, okay. And in first problem, the probability that sum is neither 8 nor 9, no, sir.
Neither 8 nor 9 means no 8 and no 9. Is it correct?
So how we'll know whether we need to take and or intersection or union?
See, what is the just English meaning only? Neither 8 nor 9. Sorry, neither 8 nor 9. What is the meaning?
Yes. Not 8 and 9.
That means no 8 or 9.
Okay. Okay, sir.
No 8 or 9. That means 8 union 9 whole complement. Neither 8 nor 9 meaning no 8 or 9.
Yes, sir.
Is it clear or
Thank
still
you.
doubt?
Yes, sir. It's clear.
Okay. Any other?
Thank you, sir.
Fine.
That's it.
Fine. Next, Harsha. Manasi.
Am I audible, sir?
Hello,
sir.
Tell me.
Sir, I still have doubt in A intersection B complement, sir.
No issue.
Sir, can you clear out, sir?
Which one?
A intersection B complement.
A intersection B complement means what?
Sir, we can also, sir, write na A minus B, sir.
A minus B. A minus B. A minus B. If A minus B, how both are A minus B? In 12th class, you might have studied in set theory. Yeah?
Yes, sir.
This is not A minus B. How will it be A minus? Okay, A minus B. Correct. A minus B means what? This complete area is removed.
Yes, sir.
Yes. Then what is the remaining part? Remaining part is A minus A intersection B only, no?
Yes, sir. But sir, if I...
1 minute. I understood. You can write like this, but in problem solving purpose, you should not write A minus B. The remaining...
Why, sir?
This remaining, what is this? Look here. This part only, no? This part only A minus B, no? Red color shaded area.
Yes, sir.
So how will it be P of A minus P of B? P of A means what? P of A means what? This area.
Probability of happening of A.
A intersection. P of A means this total area plus this middle A intersection B will also be included, no?
Yes,
that should be eliminated, no?
But sir, if we minus probability...
Listen to me. I understood what you are asking. A minus B means the total area occupied by from total of A, complete total of B is eliminated. Complete total of B is eliminated means only red colored area.
Yes, sir.
How red colored area is, that is A minus B correct only. A minus B correct only. But here, A means what? A means what? You only tell me. A means what? A intersection B complement plus A intersection B. A means.
Sorry, sir, I don't understand.
See, what is red colored area? A minus B. That I agree with you. 100% correct. But red color shaded area, A minus B means what? Red colored area, is it equal to A minus A intersection B or not?
Yes, sir. Equal, sir.
Equal. Then How A minus B and A minus A intersection B both must be same?
Sir, both are equal, then both should be same, na sir?
No. A minus B not equal to A minus A intersection B. If that is so, if A minus B is equal to A minus A intersection B, A cancel, B is equal to A intersection B now. Tell me.
Sir, according to set theory, sir.
Set theory, this first step is correct. First step is correct.
So, sir,
there listen. There we write actually numbers case only, like this. Numbers case only.
Yes, sir. Yes, sir.
We can write like that. But here, in probability, when you are writing, you should not write A minus B.
Okay, sir.
In case of set theory, that is 100% correct.
So, sir, but in other problem, how can we identify that what to use and what not to?
See, every time you should not use that minus concept. That minus concept in relations and sets only.
Okay,
but
okay, got it.
Minus concept, plus concept, relations and set theory only. In all probability problems, you will have to write like this only. Then
intersection or union.
Okay,
sir. Okay. Thank you, sir. Got it, sir.
Got it? Okay.
Yes, sir.
Any other students? Manasi, completed?
Same doubt, sir.
Clarified?
Yes, thank you.
Any other?
No,
Manasi?
Sir. No, sir.
Okay,
no,
fine. Because I am going to allow another student. Tezveer? Tezveer.
Sir, I have doubt in with or without replacement.
Tell me. See, two numbers are taken. Two numbers are taken with replacement, without replacement, no problem. Two numbers taken with or with replacement, no problem. But two numbers are drawn one after other. Suppose 10 are given. 2 are drawn at a time with replacement, 10C2. 2 are drawn at a time without replacement, also 10C2. But
10 into 10 now.
1 minute. 2 are drawn at a time with replacement 10C2. 2 are drawn at a time without replacement, also 10C2. Wait for 1 minute. 2 are drawn one after other with replacement is 10 into 10. 2 are drawn one after other without replacement is 10 into 9. Understand?
So why there is 10C2 in first case?
You are not at all concentrating. I am saying one after other. 2 are drawn at a time. One after other they did not mention. 2 are drawn at a time with replacement. First 2 are drawn 10C2 kept there, and again 2 are drawn. 2 are drawn at a time 10C2 and 2 kept there, and again 2 are drawn 10C2 with replacement. 2 are drawn without replacement. 2 are drawn at a time without replacement 10C2. But I'm not going for the next selection. Here you are not mentioned one after other. Please recognize you are not mentioned one after other. Did I mention one after other? Tezveer, do you hear me?
Yes, sir.
See, two elements are drawn one after other. First one is drawn, next another is drawn. One after other with replacement means 10 into 10. Okay, na?
Okay, sir.
2 are drawn one after other without replacement is 10 into 9. Okay, na?
Yes, sir.
But in this problem, what we did in the class, did they mention one after other?
No, sir.
So one after other not mentioned means with replacement means 2 are drawn at a time and keep there 2 again, and again 2 are drawn at a time. But next selection they did not mention, no?
Okay, sir.
One after other is not mentioned. With or without replacement will not have a meaning.
Yes, sir. Understood.
It's clear?
Yes, sir.
Okay. Vinayak, tell me. Vinayak. Vinayak, do you hear me? Vinayak, do you hear me? Phone iskra. I'm going to end the session. Vinayak, do you hear me? Next. Vishal. Vishal. Vishal.
Hello.
Tell me.
Sir, my doubt is on question number 7, sir. That you have find the third partner, the LCM of 12 and 15. Sir, how this one 960 come? That time what happened means electricity has gone, so I'm not able to see, sir.
Okay, no problem. Whenever you want to find how many numbers which are divisible by 2 or more than 2 numbers, you need to take LCM. You need to take LCM of those two or more than 2 numbers. LCM of 12 and 15 is 60.
Yeah.
So whenever you want to know how many numbers which are divisible by 60, so you need to all the numbers which are multiples of 60 will be divisible by 60. 60 multiples, 60, 120, 180, counting in this manner will consume time.
Okay.
That's why from 1 to 1000, identify what is the last number that is exactly divisible by 60. 1000 by 60, exactly divisible? No.
Yes, sir.
Count 60 into 10. 60 into 10, 60 into 10.
Yeah,
600.
sir, it's 960. 16
Count in
into
that
16.
manner.
Yeah. Okay, sir. Okay, I got it.
Okay.
And after finding the LCM part, then you need to check that number has given, then how many times this 60 will come.
Yes.
Okay, sir. Okay. That's why, sir, at the time of you have given this 8 number question.
No issue.
So when I'm going to do this question, then my answer is coming wrong. So that's why I will.
Clarified?
Yeah, clarified, sir. Thank you, sir.
Vishal.
Yes, sir.
Doubt?
No, sir. It's clear.
Fine. Vinayak.
Sir.
వాసు కొంచెం విండోస్ ఓపెన్ చేయమ్మా.
సార్ సెషన్ ఎండ్ చేయలేదా?
సార్ అది ఇవాళ రేపు సెషన్ క్రియేట్ చేయాలా లేకపోతే ఓన్లీ మండే సరిపోతుందా
సార్?
రేపు 2 days అవసరం ఉంటుందా? సార్ ఇంకోటి రేపు ఈవినింగ్ ఎగ్జామ్ ఉంటుందని చెప్పండి వాళ్ళకి. మీకు ఈవినింగ్ క్వశ్చన్ పేపర్ వస్తుంది సార్. రేపు ఈవినింగ్ 9 కి ఎగ్జామ్ నైట్ 9 కి ఆన్లైన్ అంతే నైట్ 9 కి అదే లీనియర్ ఆల్జీబ్రా ఎగ్జామ్